Hey there! In this tutorial, I'm going to be walking you through some beginner web scraping to gather data on sales and review scores for some Nintendo Switch games. Consider this. You, or a company that you work for, is currently interested in seeing if there is some sort of relationship between a game's review scores and how well it sold. As another layer, you're also interested in accounting for both the critic scores as well as the general audience scores. If I were to hand you a nice clean dataset with all the information that you'd need, then you could pretty easily run some sort of analysis. But most of the time in the real world, there won't be some easily accessible dataset that you can just pull from. So we're going to go through the process of trying to make our own. In this tutorial, I'm going to assume that you know a little bit about how to code in Python, but know next to nothing about web scraping, data manipulation, or any of the tools associated with them. Now before we actually start writing code, just a quick little disclaimer. Web scraping public data is not itself an illegal activity, but that doesn't necessarily mean that all the sites you try to scrape will be happy about it. So let's try and aim to be as respectful as possible to the sites that we're scraping, and you'll see what I mean later in the tutorial and how we can achieve this. Alright, so with that out of the way, let's go ahead and get started. Go ahead and open up your favorite IDE. I'll be using VS Code with the Jupyter Notebook extension, but you're free to use whatever you want, although I do highly recommend that you use some sort of notebook interface. If you have no idea what I'm talking about, I'll go ahead and post a link in the description that will get you set up with Jupyter Notebook, which will be a great place to start as a beginner. Alright, so first, let's start by making sure you have all the necessary packages that you'll need installed. We're going to want to make sure that we have pandas, as this is the package that will allow us to manipulate data and also present it in a nice and easily readable way. Next, we're going to install BS4, which will allow us to perform some HTML document parsing, and if that means absolutely nothing to you, essentially, what we're going to do is use this to look at a website and extract the information that we want. And then lastly, we'll go ahead and install OpenPyXL. This is an optional package that you can use if you want to export the data into a Microsoft Excel sheet, which is pretty popular in the business and industry world. But if you don't have access to Microsoft Excel, I'll show you some alternatives that you can use. You're free to install these using pip in the command line or whatever tool your IDE comes packed in with, but using this code in a notebook should work just fine. I'm going to go ahead and run it, and because I already have all these installed, it's just going to tell me that. But for you, if you don't, it might take a couple seconds, so just be a little patient. Everything that we would need should now be installed, so I'm going to go ahead and clear this output. And now I'll make a new cell where I can go ahead and perform some imports. I'm going to start by importing pandas, and I'm going to give it the alias PD since that's just what people tend to do. Now from BS4, we're going to go ahead and import beautiful soup, as that is going to be the main module that we're going to use. Now let's cap it off by importing the request, time, datetime, RE, short for regular expression, and random modules as well. These all come built in with Python, so you didn't need to install anything to access these. Now, if someone handed me this project but didn't give me any sort of guidance or starting point, then I would just go ahead and Google Nintendo Switch game sales and see what kind of information we can find. And looking through, this third link right here has the list of best-selling Nintendo Switch games on Wikipedia. And scrolling down, we see that we have this nicely formatted table of a bunch of Nintendo Switch games, as well as the copies that they sold and some other information. This seems like a great starting point, so let's go ahead and see if we can scrape this table from Wikipedia. Right now I'm looking at this table in Google Chrome, but I want to see if I can get it into Python. Switching back over to VS Code, let's go ahead and make a new code cell. I'm going to go ahead and create a variable called wiki URL, and this is literally just going to be a string of the URL on the page that has that table. And I'll go ahead and post the link in the description so you can copy and paste it from there. The next step might be a little odd if you're new to web scraping, but it's going to be very important. I'm going to create a dictionary called headers, and in it I'm going to create a key called user agent. Whenever you access a website, a user agent essentially just tells the website what kind of device, browser, etc. you're accessing on. To get this for your device, you can quickly just Google what is my user agent, take this, copy, and now go ahead and paste this in as the value for the user agent. If you don't tell a website what kind of device you're using to access it, then it's pretty common to have the website actually block you from entering it. Now let's actually interact with the Wikipedia page itself. We're going to create a new variable called response, and in response we're going to put request.get the URL to the Wikipedia page, and then we're going to specify headers equals headers so that we can pass this in as well. What this get is doing is essentially just going to the Wikipedia servers and asking them, hey, can we go ahead and load in whatever information is on this web page? To check and see if Wikipedia was actually okay with this, we're going to want to print response.statuscode. If we get 200, then that means that Wikipedia was totally cool with us accessing their site and gave us the information about the page. In your journey of web scraping, you might also see some other status codes that usually indicate something went wrong. For example, if you see status code 404, this means that you try to access a web page that doesn't actually exist. If you see 403, then this means that the web page does exist, but the site does not want you to access it and they've blocked you from doing so. In our case, I'm going to make sure that we run our imports, so all those are loaded, and then I'm also going to run this chunk, and looking at the result, we see a status code 200, which means that we were successful. Now you might be asking, what exactly from this web page did we actually retrieve in Python? The answer is that we got the HTML, and if you've never heard of HTML before, essentially what it is, it's the language that you actually use to construct a web page like this. If you press Ctrl-Shift-I, or alternatively, you can also right-click and do Inspect, then you'll be able to see all of the corresponding HTML for this website. And what we want to do is we want to look through this HTML because within it is all the information that this table holds. If you click this handy little tool up here, it'll allow you to actually go through and see what each part of the page corresponds with in terms of the HTML code. And in our case, since I'm looking for the table, I'm going to go ahead and just start by clicking on the title, and then looking around, we find this table object. Looking a little bit more closely, we can identify it by some of the class attributes that it's been assigned. So for example, it has been assigned as a wiki table. Now if we go and look around on the website, it is the only table present here, so being able to find it out of all the other parts of the web page shouldn't be that hard, as we really just need to look for a table that is a wiki table. Let's now go back to our code, and I'm going to go ahead and make a new code chunk. In this new code chunk, I'm going to create a new variable called soup, and we're going to equal this to beautiful soup, parentheses, response.text, and then pass in as well a string called HTML parser. Beautiful soup is the module that's going to handle all of the HTML parsing. Response.text is literally all the HTML that you previously saw when we were inspecting through the web page. And then HTML parser, this will tell the beautiful soup object that we are giving it some HTML code. Let's go ahead and call soup, and then we're going to run this chunk. And then what you will see is literally all of the HTML code that we saw before, except now because we put it in this beautiful soup object, we're going to be able to go through and actually look for the individual parts of it. We want to find that table, so we're going to equal a new variable, HTML table, to soup, which is our object right here, dot find. We're looking for a table, so we're going to pass in table as the first argument, and then as the second argument, we're going to pass in a dictionary where we're going to specify that the table class we're looking for is a wiki table. Now, if we run and print this, we can see that we actually just went through all the HTML and found all the code that corresponds to the table that we were looking at earlier. So we found a way to read in the table into Python, but in its current form, it's really not going to be much use to us. So now is where we're going to use pandas. Let's go ahead and make a new variable, which I'm going to call switch sales df. df is going to be short for data frame, and you'll see what that looks like in a little bit. I'm going to call pandas through its nickname pd, and then we're going to use the .readHTML function. And what this will actually let us do is take that HTML table and convert it into something more readable. So inside the parentheses, I'm going to put the HTML table variable, and then I'm going to wrap it around the str or string function, just so that it passes in as a Python string, as readHTML will like this a lot better. Lastly, as a little quirk of this function, the data frame, which is the object that we're actually looking for, is on the 0th index. So we got to do brackets 0, and now we'll be able to access it. Let's go ahead and print our switch sales df, and when we run this entire chunk, now we get something like this. So we've now read in that Wikipedia table with all of our Switch games, as well as the information that we want on them, such as the copies sold, and as of when that information was collected. And this is a great start, but just looking at this table, I can already see that there's going to be some issues that if we don't address them now, they're going to be further down the line a big problem. For one, this copies sold column is being read in as a string. So if you try to perform any math on any of these numbers, it's not going to work because the computer is going to recognize it as a text character instead of a number. The as of and release date columns are also going to suffer from the same issue. For example, if I wanted to sort all my games by the date that they were released, then when I try to run a sort function, it's going to sort these alphabetically instead of by the date. To address this, let's go ahead and create a new code chunk, And in this code chunk, we're going to write some functions that will translate all of these into what we're looking for. I'm going to start by defining a new function, which I'm going to call copy sold to numeric. As an input, it's going to take a value, which is going to be one of these cells in the copy sold column that I have highlighted above. If we're looking at the values themselves, there's a couple things that we need to do to make it so that only the number remains. First, we got to get rid of this million, as well as the brackets and whatever number is currently in there. In my function, I'm going to create a new variable, which I'll call parse string. Now I'm going to paste in the code to remove all those unwanted characters, and then while you go ahead and write that out, I'll explain what each moving part does. In case you've never heard of them before, a regular expression, also known as a regex, is essentially just a pattern or rule that you can use to find certain parts in text. So in our case, we need to look at this string right here and look for the rule that identifies the million as well as the bracket number. Once we find it, we want to remove it. To do that, I'm going to use RE, which is the regular expression package in Python, and I'm going to use the .sub function. The sub function takes in 3 arguments. The first being a pattern that we can use to identify the part of the string that we're looking for. In this case, because we're looking for the million brackets some number within the brackets, we're going to put R and then quotations. This lets Python know that we are passing in a regular expression, million, a left bracket, which we need to use a backslash. Brackets take on a different meaning when you're working with regular expressions, so we need to specify that we're looking for the character of a left bracket using this backslash. Some number of things inside the bracket, so here I'm going to specify that we can have any lowercase character, and that can occur 0 or more times, and then a numeric number, which can occur 0 or more times. We're going to close it off with the right bracket, which also needs that backslash, and then just to cover the case, where it doesn't have a reference and we only have this million, we're going to put this little star at the end and wrap everything around parentheses, and that'll let it know that the bracket part can occur 0 or more times. Regular expressions are actually a pretty deep topic, so if you have a hard time understanding what's happening here, don't worry about it too much for now. Just go ahead and copy what I have, and I'd encourage you to learn a little bit more about regular expressions, as anytime you're working with data, they're useful to know. The second argument is what exactly we want to replace the part of the string that we identified with. In this case, because we want to remove it, we're just going to pass in a blank string, and this will just go ahead and get rid of it. Lastly, the third argument is just the string itself that we're going to be manipulating. So just go ahead and put value. So we've gone through and extracted the actual number of copies sold. Now what we need to do is we need to cast that number back into a numeric, which we can do using the float function. And then we're going to multiply it by 1,000,000, as that's the way it's actually written. So we want to make sure that we account for that. Go ahead and return it when we're done. Now, to show that the function we made is actually working, let's go ahead and make a new code chunk. And then inside this new code chunk, I'm going to create a new variable, which I'm going to call switch sales df formatted. Rather than directly overriding the old data frame, we're going to store all the changes we make inside a new one. I'm going to do switch sales df, which is our original data frame, and then I'm going to use the .assign method. And then let's go ahead and make some room to pass in some arguments to assign. Assign will go ahead and create a new column in our data frame. And what I want to do is I want to create a new column, which I'm going to call copies underscore sold. This will be the copies sold column that we saw earlier, except ran through our function, so it's nice and cleaned up. To perform this, we're going to need to use a lambda function. In this case, the lambda function will be a simple little helper function that will allow us to take the column that we're interested in, i.e. the copies sold column, pass it through that function, copies sold to numeric that we just made, to clean it up, and then store all that information into the new column. We're going to define it as lambda df, and this essentially just says the current data frame that we're working in is going to be denoted as df, so things can be written a little bit easier. And then in our function, we are going to want to extract the copies sold column from df. On this column, we're going to want to perform the map function. This allows us to take each number in our column, perform some sort of function on it, and then properly align it with its original one. In this case, we're going to do another lambda function where we're going to pass in a value, which I'm going to call var. And this is essentially just each little cell in our column for the copies sold. And for each of those values, we're going to pass it into the copies sold to numeric function that we made up here, convert it, and then we're going to properly align it and create that new column. So now we have code written to go ahead and make that new copies sold column with everything casted to the correct data type. Since we did that, we really don't need the old one anymore, so we're going to go ahead and drop the old copy sold, and it's missing the underscore column. To do this, we're going to do the dot drop method. Inside, we're going to have the columns argument equal to a list. In this case, we're going to have a list of our string, copy sold, and then we're going to make sure to denote that the axis equals ones. This just means drop the columns. Let's go ahead and see our function in action. So make sure you go ahead and define it if you haven't already done so by running that chunk. And now if I call the switch sales df formatted, run that all together, and if we go all the way to the right over here, we see that we have our copy sold column, and it is now casted to a numeric with the correct data type. In this case, for Mario Kart 8, we have that it sold 53 million and some change copies. So that's one problem done. Now let's go ahead and handle those dates. We're going to go ahead and make another function. I'm going to go ahead and call this function convert date, and it's going to take in a date string as its argument. Similar to last time, we need to identify the pattern that our date is currently written in so that we can parse it. And if I look down here in either of these columns, you can see that we have the month followed by the day, comma, and then the year. To denote this pattern, we actually don't need a regular expression here. I'm going to create a new variable, call it format type, and we are going to denote the pattern by using this %b, %d, then the comma, and then %y. And what this does is tell Python that the format is going to be of the type month, day, comma, year. Now to actually do this, we're going to need to use the datetime module that we imported earlier. Let's create another variable, which I'm going to call datetime_str, which is just short for string. Next, we're going to call datetime.datetime.strptime. This datetime refers to the package datetime that we imported. Then we're going to have a datetime object, which is essentially just an object that allows us to manipulate dates and treat them as they should be instead of strings. And then finally, we're going to call this function right here, which will allow us to actually take a string and turn it into a datetime object. For the inputs, we're going to pass in the date, which is the string, and then we're going to pass in the format that it's currently in. Lastly, I'm going to go ahead and return the datetime object, but I'm going to use this strftime function to put it in a different format. So I'm going to put it in the month, day, year format. This will be a much friendlier format, so if you pass it into, say, Excel will be able to recognize it and allow you to do things like sort the dates however you want. If you're working purely in Python, then honestly, you can also just get rid of this part, as you'll just be more concerned with the datetime object itself. But to make things a little bit more flexible, we'll go ahead and keep it. Now let's go ahead and go back to our assign function. And I'm pretty much going to follow the same process that I did before, except the columns of interest are going to be a little bit different now. So we're just going to put release_date and as_of_, and we're going to equal these to our same lambda functions, but the only thing different is that we are going to change the function to convert dates, and then we're also going to change the column that we're performing the map on to the one of interest. So up here we have the release date column, and then down here we have the as of column. And then lastly, we're going to drop the original versions of those columns as well. So go ahead and go to the columns arguments, and inside that list, we're going to add release date and as of. Feel free to pause the video if you need a second to write all that down. I'm going to go ahead and scroll up a little bit and make sure all these functions are defined so we don't get any errors. And then now when I go ahead and run this, we're going to get something like this. We see that our release dates and our as of sold are now formatted in a much friendlier version. So we have our table set up pretty nicely now. We have the copies sold in numeric form, and then we have our dates formatted a little bit more nicely. Just as a little aside, if I were actually doing some sort of analysis, I would really want to consider maybe normalizing this copies sold column, as it may not be fair to compare a game that has been on sale for 10 years versus a game that has been on sale for 5 years. But we'll save that for a different time. So now we have one half of the equation done. We have our games and the sales that we were able to scrape from the web. But now we need to be able to get the review scores for them, because remember, the original context of the problem is that we want to see if these review scores might have any influence over how many copies the game sells. Unlike with our game sales in Wikipedia, let's assume that there is no nice table out there that exists of all of our games and their corresponding Metacritic scores. Whether this is the case or not, I don't really know, but even if it was, you'd have to rely on someone else to consistently update that table for you, which we don't want. The best we can do is go on the Metacritic website, look at an individual game. So here I have Mario Kart 8 Deluxe, And then from here, we can garner its Metacritic score, as well as its user score, and the number of ratings for each. What we want to avoid is to manually have to go through, find all these pages for each of our games, and then go ahead and write down the Metacritic score, user score, etc. We want to see if we can find a way to automate this process. I'm going to exit out of full screen shortly so we can take a look at the URL, and we can notice a little bit of a pattern. First, it seems to start with metacritic.com/game/switch, letting Metacritic know that we're looking for a game for the Nintendo Switch, and then we have the title itself, as well as /details, and this will take us to this page. Now, if I were to change the Mario Kart 8 Deluxe to, say, Super Smash Bros. Ultimate, where instead of spaces, we have these little dashes, and I go here, let's see what happens. And now we're brought to the Super Smash Bros. Ultimate details page. So it seems like there's a bit of a schema going on here that we can potentially exploit to automate the process of finding all the Metacritic pages for our games. So heading back over to VS Code, let's go ahead and make another function that will take a game's title and generate a Metacritic URL. We'll call it create Metacritic URL, and it's going to take in the title of the game. Some of our titles are going to have interesting or weird characters that will not work in a URL, so we're going to have to go through a little bit of a process to make sure that those are gotten rid of. I'm going to create a new variable, which I'm going to call mod title, which will just be short for modified title. Let's get rid of all those weird characters such as periods, colons, commas, etc. And I'm going to do this using the re.sub function that we used before. And once again, learning about regular expressions is really useful, so I'd encourage you to look a little bit more into it. Next, let's go ahead and replace all these spaces in our game's title with that dash so it can fit the syntax of the URL better. Since we're not really looking for any complex patterns, we don't really need to use a regular expression. We can use the .replace method for strings. So we'll use that and we'll look for a space, and if we find it, we'll replace it with a dash. And then just because I got a peek at the list before and Pokemon is on the list, we're also going to want to replace that little E with the accent with just a normal E, as this will make our URL play a little bit nicer as well. So we've modified our title to get rid of any characters that would mess with the URL. Now let's actually generate the URL itself. First, we're going to want to create a string where it has that first part, so it's going to be metacritic.com/game/switch. Then we're going to want to take our title that has been modified and cast all the characters to lowercase. And then lastly, we're going to put the /details at the very end. And we're going to go ahead and return this string. And now using this function, we can create a new column in our Switch sales data frame. And this column is going to be the Metacritic URL. And because we're creating a new column, we are going to want to go into the assign function. And now we're going to want to create another lambda function to handle this. I'm going to call the new column Metacritic URL with the underscore. And then we're just going to follow the same process that we had before, where we call our lambda function with our helper function. The only difference being is that we're going to pass in the title column, and also make sure that you have defined the function above. So we'll run it here. And to avoid any syntax errors, make sure you append that comma if you didn't. Now, when I rerun this whole chunk, we are going to get the same data frame we had before, except now we have this new column, Metacritic URL, that has a generated Metacritic URL for each of the games. Now, whether or not all these URLs are valid is a little bit up in the air right now. For example, if we look through the table and we see Pokemon Sword and Shield, well, these are two different games that have only gotten one entry and had their sales combined. So generating one Metacritic URL for both of them may not work correctly. But at the very least, it'll be a good start, and we can see if we can gather as much information as possible without having to touch anything manually. So before we attempt to try and scrape all the games, let's just see if we can get a scrape working for one game, and then we can automate the process from there. So I'm going to go ahead and make a new code chunk. So just like with Wikipedia, let's go ahead and use the request library again. I'm going to do request.get. Inside, we're going to pass in the URL to the Metacritic page for Mario Kart 8 Deluxe, which is just going to be the game that we're going to sample with. And then I'm going to also pass in the headers as well. Remember that we need to tell Metacritic what kind of device we're currently working on. Just to make sure that it works, let's go ahead and get the status code for this. And if we run the whole chunk, we get a status code of 200. So we're in business. Now let's go ahead and HTML parse, which was done using beautiful soup. So we're going to create the soup variable, and we're going to equal this to beautiful soup. We're going to pass in the HTML, which is in req.text. And then of course we need to let it know that this is an HTML and to use the HTML parser. Now for the fun part. We need to go through the HTML page and find out where all the data that we're interested resides. So let's just go ahead and do Control-Shift-I if you're on Windows, or you can do inspect from the right click, look through and see what kind of information we can gather from this page. So first of all, let's go ahead and grab this summary, which I think would be useful for just making our table a little bit more complete. But we're mostly going to be interested in the Metacritic score right here, the user score right here, as well as the number of reviews from each of these. So let's go ahead and start by trying to capture the summary. If I look around, I can see that there is a whole div dedicated to the summary itself. And then if I dive a little bit deeper and look at what is inside this div, we can go and look and find that we have this span of class data. And this is what actually holds the text for our game summary. So let's see if we can find it using code. We're going to create a new variable, which I'm going to call description. And using this variable, we're going to perform a search on our soup object. So our summary exists in a span of class data, but there might be situations where there are other spans of class data that aren't our summary. So to make sure that we're pulling from the right one, first, we're going to want to find the div that contained the summary itself. So we're going to do soup.find, we're going to look for a div, and then we're going to look for the class corresponding to the summary. In this case, it was summary detail space product summary. Once we've found that div, we can then stack another find on top of it. So inside that div, we're going to find the span of class data. And this is where our summary is held. And to extract it, we can just use .text. So now if I run all this together, you can see that we make the request, look for the description, and when we find it, we get what looks to be the description for Mario Kart 8. So it's working pretty well. Now let's go see if we can extract the review score as well as the number of ratings using the same idea. So I'm going to go poking through the HTML a little bit. For the score itself, we can see that it is in a span. Here's 92. And then we can follow the tree up to make things a little bit more specific so that we don't get the wrong thing. So I can see that it exists in a div of class Metascore wrap, and then it also exists nested within this anchor. So let's go ahead and go to VS Code and see how we can extract it. Let's go ahead and create a new variable, which I'm going to call Metascore. I'm going to do soup.find, and I'm going to look for a div that has the class Metascore wrap and feature Metascore. Since there's only one span inside that div, and it's exactly what I'm looking for, I can go ahead and just do find span, and then get the text out of it. So now you can start to see how I'm finding all of these. And for the sake of speeding things up, I'm just going to go ahead and write out all of the code for the individual elements. But I'd encourage you to go through and see if you can write your own code to find them and see how it compares to mine, as there's more than one way to do this. So we want to get the number of critic ratings. So I'm going to store this in a variable called meta ratings. I'm going to do soup.find. We're going to look for a div of class Metascore wrap feature Metascore, since it's in the same place as the score itself. Next, we're going to look for a div, and this is going to be of class summary. We're going to follow this by looking for a p, and then finding a span on top of that of class count. We go into one more anchor, and then the span inside this anchor is the text that we're looking for. So I'll give you a second to pause the video if you need to do that, but we can go ahead and test it. So now if I print meta ratings, you can see that we do indeed get that 95, but we also get a bunch of blank space around it. So in a second, we'll find a way to deal with that. Let's now look for the user score. I'm going to do soup.find, and we're going to look for the user score wrap feature user score, which is kind of similar to what we had above, but a little bit different. I'm going to next look for an anchor, and this anchor is going to be of class Metascore anchor. And then I'll find the div and extract the text from there. So we can run this to make sure it's giving us the right one. And now when I run it, I get a user score of 8.6. Now we just need to find the number of user ratings. So to do that, we can go through, create a variable called user ratings. We are going to soup.find, and we're going to go into the user score wrap feature user score. we're going to find a div of class summary. Once we do that, we are going to find a span, and then this span is going to be of class count. And then lastly, we're going to extract the text from it. So if I go ahead and run this, you'll see that we get a string that does have the number we're after, but it's got a couple of other things that we don't want. So just like with the meta ratings, we're also going to have to modify the user ratings a little bit as well. To extract just the numbers and nothing else, we can go ahead and use a regular expression. I'm going to use re.findAll, and then for the pattern I'm looking for, it's just going to be one or more digits. We'll pass in our original string, meta ratings, and then because findAll returns a list of all the times that it detects the patterns, we're just going to want to return the first time that it detects it, as this should be enough for the purpose of this exercise. And then we can just override the original value. So if we do that and then we print meta ratings, you'll see that now we get 95. We can do the exact same thing for user ratings. It's going to be the exact same pattern. All we really need to do is just change this. And if I go ahead and print that one as well, you'll see that we get the correct number. And then just to demonstrate that everything's working together, let's go ahead and create a dictionary. And this dictionary is going to contain all the information we collected above. And then we're also going to cast the scores to numerics. So now if I run all this together, you can see that we get our description, our metascore, our meta ratings, our user score, and our user ratings all together. So we have all the logic we need to scrape all the relevant information for a single game. But now what we want to do is generalize this process into a function so that we can go through each of our games in the table and perform this scrape. For the most part, this should just be a matter of copying and pasting all the relevant parts. So I'm going to go ahead and make another chunk, and I'm going to create a function which we'll call scrape Metacritic. Now I'm going to scroll up, copy all of this up to the soup. I'm going to exclude the request because I'm going to want to handle that outside of this function. And then we can just go ahead and paste it all in and perform an indent. And then rather than doing nothing with the dictionary, let's make sure that that's getting returned. Let's also go ahead and change the request.text to HTML. So what we're going to do is pass in the HTML text directly to this function. And then once we do that, it'll go ahead and do all the parsing. Just to demonstrate that this is still working like we think it should, let's go ahead and try it by running scrape Metacritic. And then in the inside, we're going to pass rec.text. And if we run that, you can see that we get our dictionary still. So what we're going to want to do now is attempt to parse each of the URLs in our Switch Games data frame using this function. So I'm going to go ahead and make a new code chunk, and we can handle the logic here. First, let's go ahead and get all the URLs that are in our Switch Sales data frame that we generated, and let's go ahead and make that into a list. That way we can iterate through each of them. So if I do URLs is equal to Switch Sales df formatted, and then I access the Metacritic URL column just like you would with a dictionary, and then perform the .toList method, you'll see that it's going to take that column, and now it's going to return a list of all the URLs that we generated. I'm going to define a new variable called Metacritic results, and this is just going to be an empty list. So every time we go through and use that function to try and parse one of the URLs, whatever results we get from it, we'll place it in this list. Let's now go ahead and create a for loop so we can iterate through each of these URLs. So I'm going to do for URL in URLs. The first thing we're going to do is attempt to reach that URL. So we're going to do that using the request library. It's the exact same syntax as before. The only difference being is that whatever URL we are currently iterating on is what's being passed in here. Before we try and actually perform the scrape itself, let's see if we can actually reach the web page we're looking for. So we're going to perform a check to see if the request status code is 200. If that is indeed the case, then we can just go ahead and perform our scraping logic here, which we will fill in shortly. If we see anything else that is not a 200 status code, that means that we weren't able to successfully reach the page, so we're going to want to denote the error so that whoever's looking at our data can see that. Now usually in practice, web scraping is not a one-size-fits-all solution, so there is the possibility that even if we are able to reach a valid web page, for some reason it's going to be built a little bit differently than the others, and we're not actually going to be able to extract all the information from there. So what we can do to handle this, rather than getting an error every time, is we're going to perform a try and except. What this is going to do is it's going to attempt to parse the web page, and if it's able to do so successfully, then we'll be good to go. But if it can't and it reaches an error at one point, then we can handle that case as well, where we can just return an empty result and denote that it was able to reach the web page, but not able to parse it. So whether we're able to successfully scrape the URL or we fail to do so, we're going to want to append the result to a list so that we can transform that list into a data frame eventually. So whatever happens, we're going to append the result. And then lastly, to be respectful to Metacritic, we're going to want to perform a random delay between our scrapes. Although nothing we're doing here is really that insane in terms of the amount of requests that we're going to send their way, we do want to be respectful and we want to make sure that we don't overload their servers with a bunch of traffic. In practice, if you're doing a lot of scraping, you might find that some websites will catch on if you just throw a bunch of requests at them and start to block you, which will mess up your scraping. So what you can do to get around this is you can perform a random delay that makes your scraper feel a little bit more human. And since this tutorial is for learning purposes and nothing here is going to be a life or death matter, we'll set a generous delay that shouldn't be too different from what a human could probably do anyways. So this is all the logic written out. Now let's go ahead and actually fill it out with some code. We'll start with the most trivial case, which is going to be if we can't actually reach the web page. If this is the case, then what we're going to want to do is return an empty dictionary. I'm going to store it in a place called current URL results. We're going to return our dictionary that we've seen above, except it's going to have all the fields empty, and then with a couple of exceptions. We're going to want to denote the status code as whatever status code we received that wasn't 200. We're going to want to place the Metacritic URL here. This is going to be important so that we can join it with our switch sales data frame from before. And then we're also going to want to add this key right here, parsed. That'll just let it know that we were not able to parse the web page because obviously we weren't able to reach it. Now we're going to go up to our try block and we're going to write out the code to actually use our scrape Metacritic function to try and scrape a web page that we were able to successfully reach. So what we're going to do is we're going to use the same current URL results and we're going to equal it to the result of scrape Metacritic. Remember that we're returning a dictionary in the function up here. So if we're able to successfully scrape and it goes through the function correctly, then this will return a dictionary. Once we get that dictionary, we are going to append some of those missing keys that are not up above. So the Metacritic URL, the status code, and then the parsed. We're going to denote this is true. We're going to put the status code as 200, and then we're also going to append the URL. In the case that we are able to reach the web page, but for whatever reason, this scrape Metacritic throws an error, so maybe the page is built a little bit differently, or there's not enough information collected on the game and it displays a bunch of blanks, we're going to want to be able to handle that too. So we can kind of just copy what we have here, return this blank URL, except we're going to want to make sure that the status code is reported as 200. So that way anyone who's looking at the table you create can see that the web page does indeed exist, but for whatever reason, we weren't able to successfully parse it. One alternative way to write this code is that you can assume that the page is not scrapable by default, so you can start with the blank dictionary and adjust it as such depending on what happens, but I'll let you try that for yourself. Now we need to handle the last two parts of our logic. So first, we need to append the results, and this is simply going to be done by using Metacritic results.append, and then we're going to append the dictionary that we currently made, and it's going to be either one of these three cases. Now we need to perform the random delay, and to do that, I'm going to make a little helper function up here. So we're going to create a new function, which I'm going to call perform random delay. This is going to take in two inputs, the first one being the amount of time in seconds that we want to delay, and the random offset being a little bit of extra time that we can add to our delay to make it seem a little bit more human. So in this case, if I make it 0.5, then the goal here is that we're going to delay by 3 seconds, plus some time between 0 and half a second. To actually perform this delay, we can use the time.sleep function. What this is going to do is just pause Python, so nothing's going to be happening for however many seconds you decide to put in here. We're going to put in our delay, which I have defaulted to 3, but you can set it to something higher if you would like. And then you're also going to want to add random.uniform, where this just generates a random decimal number between 0 and whatever random offset we put in here. So like I said, in this case, it'll be a random number between 0 and half a second. Let's go ahead and run this chunk so that we can define our function. And now I'm going to scroll down here and we're going to go ahead and add it to our logic. So right after we append the result, we're going to perform our random delay. So this is everything we need to go ahead and perform a scrape for all of our URLs. So let's go ahead and run the chunk and then we'll give it a little bit to run. I'll go ahead and speed up the video here, but please resist the urge to skip this step and make sure we're being nice to the site that we're scraping. Even with our, what I'd say, pretty generous delay, we were still able to collect all this information in about 5 minutes. Let's go ahead and make a new chunk, and we're going to see if what we did actually worked. If I go ahead and print out the list Metacritic results and see what we got, you can see that we have a bunch of results, but they're not in the most readable form at the moment. But thankfully, because we saved our results as a list of dictionaries, Pandas has a pretty easy method to make this into a data frame. So all we have to do is we're going to use pd.dataframe and pass in our list of dictionaries. And additionally, I'm going to store this in a variable called reviewsdf. So now, if I go ahead and print it when I run this chunk, you'll see that we get a data frame like this. We have our descriptions, our scores, as well as our URLs, and a status code detailing if we were able to parse it. So looking through this right here for Pokemon, we can already see that this one got a 404, which makes sense because in the Wikipedia table, it attempted to combine the two games, when on Metacritic, they most likely have their own individual pages. So we've created two data frames in this tutorial. We have a data frame of the Nintendo Switch games and their sales, and then we have another data frame of our attempted Metacritic scrape. What we want to do now is combine these two data frames and then do a little bit of validation checking by seeing how many of our scrapes were actually able to be successful. I'm going to do a new code chunk, and I'm going to create a new variable which I'll call Switch Sales Reviews DF, and this is going to be the combined effort of the two. First, I'm going to put the original Switch Sales DF formatted, and then I'm going to use the merge function, where here I'm going to put the reviews DF. And what this will do is it'll merge our two data frames based off a common key, in other words, a column that they share. I'll let you have a second to take a guess as to what column that would be. If you said the Metacritic URL, then you are 100% correct. And that's why it was important that we stored that information when we were going through and scraping all the websites. So now, if I go ahead and print the results, and I run this chunk to merge the data frames, you'll see that we get exactly what we expect. We have our games, we have the release dates, the copies sold, the Metacritic URL, the Metacritic description, as well as all these scores. Before we export this information, let's actually go through and see how many of the Metacritic URLs were actually successfully parsed. First, let's go ahead and take the sum of the parsed column in our Switch Sales Reviews DF. Remember that when we wrote this out, this was denoted as a binary value, so if it was successfully parsed, then we get a value of 1, and if it was not successfully parsed, then we got a value of 0. So taking the sum will give us the total count of successfully parsed URLs. Now, to get the percentage of success, we just need to divide by the total amount of games there are in our table, and to do this, we can just get the number of rows in our table, since each row represents a different game. To access the number of rows, we can call our data frame, and then use the .shape function and get the 0th index, as the shape returns the number of rows and columns, with the number of rows being 0 and the number of columns being 1. So now, if I go ahead and run this, we see that we get a number of about 88%. So of about the 80-ish or so games that are included in this table, 88% of them were able to be completely successfully parsed, so we have information about their sales as well as their review scores. Like I said before, web scraping is hardly a one-size-fits-all solution to getting a bunch of data. So what you can do is, since we've denoted whether the page was successfully parsed or not, as well as an error status code, is you can think of a schema to either collect the information that is missing, or if you can just determine that it's not really worth the effort, you can just drop it and just continue with the information that is readily available. And to cap off this tutorial, I'll show you how you can export this data, just in case you want to read it into some other software and perform some analysis on it. If I call my data frame, Switch Sales Reviews DF, and then use the .toExcel method, then I can just export this to an Excel file, assuming that you had installed that OpenPyXL from the beginning. I just need to put in a file name, so I call it Switch Sales and Reviews.xlsx. Make sure you put the extension, as this is pretty important. And then I also set the index to false, the index being this number over here. We don't really need this number, so we're just going to choose to not include it, and you can do that just by setting this to false. Alternatively, if you either don't have Microsoft Excel or you just don't like the way it's structured, you can also export this to a CSV, where a CSV is just another type of file to handle structured data. Now if I go ahead and run this chunk, you'll see that the two files show up on the left-hand side over here, as they were generated in the same directory. And just to give you a peek of what the final result looks like, Here's all of our games, and then as you can see, we have plenty of them with the user scores and user ratings filled out, and we have a couple that are missing it, specifically those Pokemon games, but for the most part you can see that it was actually relatively successful. Hopefully you enjoyed the tutorial. This is by no means an exhaustive look at web scraping, but it is a nice little example of taking a real world problem and doing your best to try and gather as much information as possible when you have to start from absolute scratch. Feel free to leave a like or a comment if you enjoyed the video, and maybe even consider subscribing if you want to stick around for more content. I wish you the best, and I hope you all stay safe and take care.